Hi everyone, this is the next video and I'm going to start with this question here. So it says given sine theta equals 3/5 and theta is obtuse, find the exact value of cos theta and tan theta. So just get you to have a think about this first. There is a hint on the right there, so just pause the video and see if you can have a go. Okay, now there's always students that want to do this step, so they think, right, if sine theta equals 3/5, then theta is sine to the -1 of 3/5. If I put that into my calculator, I get 0.6435. Now let's make sure we're working with a full decimal here. So I might even store it in my calculator. And then some students think, right, well, cos theta is going to be cos of that answer. And then when I do that on the calculator, I get 4/5. And tan theta, if I do the same thing, so work that out on the calculator, I get 3/4. Now it does say exact value. If you didn't use a whole decimal, you wouldn't have got there. But nowhere in this question we've taken account of the fact that it tells me that theta is obtuse. Okay, so students always want to try and do this method. It won't work for all questions. We need a different approach. Sometimes you won't even get an exact value for your final answer if you've used a calculator. So I'm just going to write these at the side of what the calculator gave us. Let's see if it was right for this question or not. And I'm going to go down the hint route. So it tells me to use a right angle triangle and Pythagoras. The first thing I'm going to think about is if theta is acute. So if we've got an acute angle between 0 and 90 degrees, I can draw a right angle triangle. So I'm going to draw a right angle triangle here. And that'll be theta. Okay. Now using what I've been given, sine theta is 3/5. That means that the opposite side is 3 and the hypotenuse is 5. So I'll just label the sides as well so you know where that's come from. That means I can find the adjacent side using Pythagoras, because the adjacent side will be 5 squared minus 3 squared using Pythagoras' theorem. So that's 25 minus 9, which is 16. And then I'll have to square root the 16. You may also recognise that that's a Pythagorean triple. So you have a well-known right angle triangle with sides 3, 4 and 5. Okay, so that's the first thing. I'm just forming my right angle triangle, and basically I'm assuming that theta is acute. So I can put that somewhere. If theta is acute, or assume theta is acute. Now, if theta is acute, cos theta would be the adjacent over the hypotenuse, so 4/5. That's what the calculator gives us. And if theta is acute, tan theta would be equal to opposite over adjacent, which is 3/4. And again, that's what the calculator gives us. But it tells us that theta is obtuse. So what I'm going to have to do now is I'm going to have to rely on the cast diagram. Because remember, there's angles on here all around the cast diagram. So the positive angles are there. If you remember from when I first introduced the cast diagram, the first quadrant here, 0 to 90, the angles are acute in there. The second quadrant, angles 90 to 180, they're obtuse. The third quadrant, angles greater than 180, we've got reflex. And we've also got reflex angles there. So the section we're interested in is the obtuse section, where the angle is obtuse. Now, in this section, sine is positive. Okay, we know that from the letter, and we know that from our work already. That's why we've got a positive value here. So, is sine the only graph that is positive? Well, yes, it is. So, if I'm trying to do cos of the angle or tan of the angle, the answers must be negative. So, if theta obtuse, cos theta is going to be minus 4/5. I'll have to change the sign. And for this one as well, if theta is obtuse, which it is, then tan theta is going to be minus 3/4. Because we're in that quadrant where only sine is positive. So let's just make that clear. Therefore, cos theta is minus 4/5 and tan theta is minus 3/4. So the calculator, even using that way, wasn't actually right because it was treating the angles as acute. Okay, that question is actually in your notes, so you can be writing that in. You can pause it and make sure it's written in. There are 2 other questions that are also in your notes. If you feel you've understood this, you can pause the video and have a go, and then I'll be talking through it when you press play. If you're still unsure, you can watch my explanation now and fill in your notes at the same time. So if I do part A, I'm going to do the exact same process. I'm going to draw a right angle triangle, use Pythagoras and a bit of trigonometry. I'm going to treat the angle as acute to begin with, and then I'm going to address the fact that the angle isn't acute. So in the first one, it's saying the angle is reflex, and I only need to find the value of sine theta. It should say exact value there. Most of these want exact values. So I'm going to say that I've got a right angle triangle then. I tend to draw it the same regardless of what numbers I've got, but you can keep it to scale. So if cos theta is, I'm just going to look at the positives, so 3/5, it'll be 3 and a 5 here for the adjacent and the hypotenuse. So the opposite side, just like the last one, it's going to be 4 because it's a Pythagorean triple. Now, if theta is acute, then sine theta will be equal to opposite over hypotenuse, which is 4/5. I could find tan, but I don't need to. So now I'm going to go to the cast diagram and think about what quadrant I'm in. So this is acute angles, obtuse, reflex, and reflex. Now there's two reflex sections. Okay, so I'm either going to be in the 180 to 270 section or the 270 to 360 section. There is one giveaway, and the giveaway of knowing which one it is to do with this. It's telling me that cos theta is negative. So where is cos negative in the reflex sections? Well, this one here. So I have to go for this one. This is where cos is negative, and I want a reflex angle. The other section is where cos is positive. So if it was cos theta equals 3/5, then I'd be in that section. Now tan is only positive in that section. So if theta is reflex, sine theta is going to be negative 4/5. Okay, I'm going to the next one then. So this time we've got sine alpha equals 2/5, and we're told that alpha is obtuse, and we're finding the exact value of cos alpha. So same thing, right angle triangle, treating not theta anymore, treating alpha to be acute. So opposite 2, hypotenuse 5. Now this isn't a Pythagorean triple, so I'm going to have to find the adjacent side through Pythagoras. So I could say a squared equals 5 squared minus 2 squared. That's going to be 25 minus 4, which is 21. So a is the square root of 21. Put that on the diagram there. So if alpha is acute, then cos alpha is going to be equal to a over h, root 21 over 5. I could find tan alpha as well if I need. Now it's talking about obtuse. I'm just going to use the cast diagram up here so I don't have to redraw another one. So this is where obtuse angles are. And in this section, sine is the only graph that is positive. And you can see it tells us that here sine alpha is positive 2/5. So if I've got an obtuse angle then, if alpha is obtuse, I will need to make cos alpha negative. Okay, so that's just a little section on those types of questions. They're quite common. We do see them again in year 2. Next, I'm going to move on to something called powers of trig functions. Okay, so we're going to see something like that, or this, or that. Now what this actually means, and you may have seen this before, but it's shorthand for that. So it's having a sine theta squared, a cos x squared, a tan theta squared. And mathematicians can be quite lazy, so rather than having to write the brackets with the power, if you see a power in between the trig ratio and the angle, you know you've got a sine theta squared, etc. Okay, so make sure that's in your notes if it isn't already. They are equivalent. So we're going to have powers in our trig functions now and powers in our equations that we need to solve. So you can see straight away on this one, I've got cos squared x equals 0.25. That's how we would read it. So cos squared x equals 0.25. And the same process where I'm trying to solve each equation in this range. So the first thing I'm going to do for the first one is just rewrite it as this and think about what I would need to do to solve that. And if you spotted it, I want to square root both sides because I want to be left with like a cos x to find the principal value of. So if I square root both sides, I'll get cos x. Now be careful here. It's going to be plus or minus root 0.25. And if you actually work out that square root of a quarter, it's going to be a half, but you've got two solutions, positive 0.5 and negative 0.5. So what I'm actually going to do from here is I'm going to do two separate solves because I've got one for cos x equals 0.5 and I've got another one for cos x equals minus 0.5. Now these from here on out will be the exact same process as what you're used to doing. So principal value, same with this one, you'll have two principal values. Okay, and then the same process will be. So the first principal value I'll get is 60. The second one I'll get is 120 degrees. Now I'm just going to continue working with one. You can do this, you could work with one and then go to the other. So from here I need a cast. Looking at the range, I'm only going to be going between 180 and 0 and then 0 and minus 180. So I'll go that way for positives and that way for negatives. Right, I'm going to think about this up here. 0.5, so where is cos positive? Well, it's in the C and the A section. And from here, I can get the value straight away. So there's going to be just a principal value there, no other values when I go to 180. This one is going to be minus 60, again, no other values if I carry on to minus 180. So I'll have x equals 60 and minus 60 as my solutions for that part. And then another cast diagram here. I always recommend two separate cast diagrams because you've got different angles as well. Still going between the same range. This time I've got a minus 0.5, so where is cos negative? Here and here. Now, if this is the first time you've seen this before, every time you've got a negative y value for cos, the angle x will always be obtuse. So rather than drawing an acute angle here and here, which some students tend to do, you have to still start from the positive x-axis and draw an obtuse angle. So 120 degrees. That's the only time you're going to get an obtuse angle is when you're doing cos to the minus 1 of a negative. So the other one will be from there as well. So if I go from the positive x-axis anti-clockwise, I'll get the 120. No more angles after that. If I go from the positive x-axis into the negatives, I'll get minus 120. Notice how these solutions are the same, just with a positive or negative sign. and that's due to the cos graph, the characteristics of the cos graph. One of them is that the cos graph reflects in the y-axis. So if I just quickly mention that, that's from 0 to 360. This is from 0 to minus 360. I'm going to get this solution here, which could be 60, that solution there that could be minus 60 for the half, and then for the minus a half, this one could be 120, this would be minus 120, so they're reflections of one another. If you want to explore this in more detail, you could use Desmos or GeoGebra, type in your original equation and see why all 4 solutions work for cos squared x equals 0.25. And actually what is happening is you're going to get everything squared, so all your y values are now positive, so it'll be a bit like this, the graph. Okay, so if you have a look at what the cos squared x graph looks like, everything will be above the x-axis. Let's go on to another one. Okay, so this one is actually a quadratic in disguise in terms of cos x. So I could do a substitution here and say let y equals cos x, and I'll have 3y squared plus y equals 0. That could be easy to work with. The more you see these, the more you'll be able to work with cos x instead. So I'll continue working with y first. What would I do if I had this now, if I was solving it? Well, I'd take a y out and factorise. So I'm getting y equals 0 and y equals minus a third. I'm going to have to swap back because I did a substitution. So it's not y I'm interested in, it's cos x I'm interested in. So cos x is 0 and cos x equals minus a third. Again, if you wanted to just jump here, you could say, right, there's a cos x in common, and then it's 3 cos x plus 1, and then you can solve from there and get where I'm up to. Okay, so I'm going to have to treat these differently then. So cos x is 0 and cos x is minus a third. We'll do the cos x is minus a third first. So principal value on your calculator. It's a negative again, so you should be getting an obtuse angle. On cast, I've still got the same range. Put the letters in. So where is cos negative? Here and here. So I need to draw an obtuse angle there. And an obtuse angle there. And I will get x is from the positive side going round anti-clockwise, I'll get the principal value. No other solutions. From the positive x-axis going to the negatives, I'll get the negative of that. So this is the same answer or solutions as what I was talking about in the last one. I can round as well, so it'll be 109 and minus 109. Now I've got to look at the cos x is 0, 1. So if I do the principal value, I'm going to do it here. You can do it at the side if you've got space. The principal value is 90 degrees. Now, we've got an issue. Because 90 degrees, if I just use this cache diagram over here, 90 degrees is there in the first quadrant. And what are we classing 0 as? Positive or negative? And how would I draw an angle with a diagonal line if 90 is a right angle? So this is where the cache diagram falls down, and it falls down when you have a 0 here, a 1 or a -1. Now it's not requiring much work, but you can't really use cast. So what you need to think about for these ones is just the graph. You need to know it anyway. So go back to the graph. I'm going between -180 and 180. I'm just going to move that over so I can make it a little bit longer. So if I just sketch a quick cos graph, starts here, crosses at 90, and then is down here at 180, sorry. Here we'll do the same thing, and then it's down here at -180. That's like your turning point, and it'll carry on through -270 and then going up to -360, same thing here. I'm only interested in between -180 and 180. So when I've got cos x is 0, that's when y is 0. This I'm getting from the calculator, 90 degrees. So what other solutions will I get in the range? Well, I'll get this one here, which is -90 degrees because of the symmetry as well. So I'll have x is 90 degrees and -90 degrees. So I had to go back to the graph for that one. Now, if your solutions are quite clear, like mine are at the bottom there, you'll be fine keeping them as they are. Same with this one. It's quite clear that I've got 2 solutions there, 2 solutions there. If yours is quite squished and your solutions are everywhere, I would recommend writing them out all together. So you could write them in order from here then and doing that. So you don't want the examiner trying to hunt for your answer. They want to be able to find it quite easily. Okay, so that one's done as well then. If I go on to the next one, this is another quadratic in disguise, a quadratic in terms of sine x. So I'm going to do another substitution. So I will get 3y squared plus 2y minus 1 equals 0. Remember, if sine squared x is sine x all squared, that's why I'm doing a y squared at the front. Now I can factorise this, or you can use your calculator. So y is going to be a third, and y is going to be -1. Now I don't want it in terms of y, I want to swap back to sine x. So if you spotted it, this one is where we're going to have another issue. So I'll come back to that one in a minute. I'll do sine x equals a third. So principal value. The principal value is 19.471. So cast. Where is sign positive? Here and here. If I go round, I'll get the principal value. I'll then get this value here. I can find that by doing 180 minus 19.417. So I'll write those two down. Okay. If I go into the negatives, I actually don't have any solutions between 0 and minus 180. So those are the only ones. Now for this one, if I do the principal value, I get minus 90 degrees. So I'm just going to think about the sine graph between minus 180 and 180. Starts 0, 0, goes up and crosses at 180. Then it'll carry on to 360. This one goes like that, will cross at minus 180 and then carries on to minus 360. Okay, so when we've got minus 1 down here, we're getting this solution of minus 90. If I carry on, the next solution will be at 270, but that's out of range. So this is the only solution in the range. Okay, so just looking at the graph again, because I've got a minus 1. I've got a 0, 1 or minus 1 for sine x and for cos x. We're better looking at the graph. Okay, so I can put on these bits as well for your understanding. Going between 1 and minus 1. Right, I'm just going to make it clear then. My solutions are minus 90 degrees, 19.5 degrees and 161 degrees. Okay, there's 2 more to do, so let's have a look at this one. A tan one, and I'm almost thankful when we get a tan one because this should be less work because I don't need to do any cast. Now looking at this doesn't look like the one before. The one before and even the one before that had an equal 0 on the right. So I'm going to rearrange first of all. And now I've got a quadratic in terms of tan. So you can work with tan x like I've said before with the others, but I'm going to do a substitution. So let y equals tan x. So I'll have y squared minus y minus 6 equals 0. If I factorise, I'll get y equals 3 and y equals minus 2 when I solve. Putting back the tan x equals 3 and tan x equals minus 2. I'm going to come up here, do the principal value of this one. On my calculator, I get 71.565, etc. I'm still within the same range, so I can't add on 180, I'll be out of range, but I can take off 180. So I will have minus 108 degrees when I take off 180, and then 71.6. For the other one, the principal value is going to be minus 63.434. So I can't take off 180, I'll be out of range, but I can add on 180. So I'll write this one first. and then when I add 180, I get 117. So I've got 4 solutions in total. Last one is a challenge to finish. Maybe just pause the video and have a think about how you're going to go about this one. Okay, so first of all, if I rewrite it as this, it could be helpful. So I'm going to divide by the 9 first. Then I'll square root. Plus or minus, remember. And then if I sort that out, I'll have the square root of 1, which is 1, square root of 9, which is 3. So plus or minus a third. Now, if you spotted it, this is something we've seen in earlier videos or earlier on the notes. You have got a transformation. You've got a transformed sine x graph. So what I'm going to have to do is think about the range. I'm going to manipulate the range. So it's originally between minus 180 and 180. Now I'm going to make it go between minus 360 and 360 because I've got a 2x. So same as before then, I will do sine 2x is a third and sine 2x equals minus a third and treat them differently. See if you can have a go at doing the principal value, finding your cast, doing the cast for both and then finding your solutions. Okay, so I'm going to jump this one slightly because it is the same as everything we've been doing. So the principal value is minus 19.471 for, sorry, got them the wrong way around, 19.471 for the third one. When you've done your cast diagram, you've got to do one full turn anti-clockwise to go from 0 to 360 and one full turn clockwise to go from 0 to minus 360. You should get these solutions in terms of 2x, so 19.5, which is your principal value, 160.5, minus 199.5, and 340.5. Try to keep the accuracy again. If you've done this one, you'll get the negative version of the other principal value. And once you've done your cast, so a full turn anti-clockwise from 0 to 360, a full turn clockwise from 0 to minus 360. Interestingly, you should just have the opposite sign to these solutions. So for this one, you will get 2x equals minus 19.5, minus 160.5, 199.5, and 340.5. Then, altogether, I've got to divide everything through by 2, because I want x. So divide them all by 2, make sure you've not rounded too much, and I'm going to write these in order, so these should be your solutions. See if I can fit one more on. Okay, so in total, you should have had 1, 2, 3, 4, 1, 2, 3, 4 from each of the equations you've solved, and then altogether you should have 8 solutions, the ones that are written there. Okay, that is the end of this video.